So, number continue just multiplication and division. So in metric arithmetic, the multiplication operator of the asterisk indicate metric multiplication. Because of an MATLAB operation can involve matrices, we need a different operator to make it minimum by element multiplication. So the operator dot multiplication, this is an array dot multiplication. So for the case, it both is the multiplication, but the purpose is same. For the particular case of our A, which is 1, 2, 3, and our B, which is 6, 7, and 8. So to multiply element by element, in this case, element, you see A have 3 elements, B got 3 as well. So multiply each of them, you use a dot multiplication. So this so its answer equal to 6, you see, 1 times 6, 6, 7 times 2, 14, and 24. So that is the metric multiplication. So when you multiply a scalar times an array, you may use either operator or either asterisk or dot asterisk or multiplication or dot multiplication. But when you multiply two arrays together, they mean uh, they mean something quite different. Just use duplication, the normal function they apply on the duplication, which is in this case would return an error message. So if you want to multiply two array or two matrices, you need to use dot multiplication. But if you want to multiply numbers with an array or matrices, that one you can either use either, but you can just use the normal multiplication. So the same syntax is all for exponentiation, dot exponentiation, and dot division. So unfortunately, when you divide a scalar by an array, you still need to use that. So for the multiplication, you can use any either the dot or without the dot. But for division, if you divide a scalar with an array, you still need a dot. But so let's see. Good. See, what multiply it in it's previously I want to choose. So let's say two, two, two directly multiply. So it's can be both. If you multiply a scalar, you refer to this number with an array A is a so you can either use with dot or without dot, but for the division, must with dot. See, but if you put 2 dot slash 3, so this is what we do by it's like 51. Okay, so if you perform the from calculation, we call the difference between the dot is the operator, as well as the slash dot slash division dot division exponentiation dot exponentiation operator. So define A set of A, add 3 to eliminate every element in A. So add 3. So this is addition. Define B, add together each element in matrix A in matrix. So 1 plus A plus B. With each element within A by the corresponding element in B. That one is dot multiplication. Square each element in A. One is dot exponentiation. Create a matrix named C of space. Even the space value from 0 to 10 with an increment of 1 can use and the colon or the D space. Yeah. The matrix. The matrix capability of MATLAB make it easy to do repetitive calculation. For example, suppose we have a list of angles in degree that we would like to convert to radian. First, put the values into a metric of 10, 15, 17, and 19. But to change the value to radian, you must multiply by pi divided by 120. So radian is equal to degree multiplied by divided by 180. So this command return a metric called radian. With the value in radians. In this case, you could use either the multiplication or dot multiplication operator because the multiplication involves a single metric and two scalar. Yes, you could have like get that written it like this, the same. But remember for division, you must use dot for division. Another useful matrix operator is transposition. The transpose operator changes rows to column and vice versa. For example, degrees. So this symbol here, like is it apostrophe, apostrophe, then that 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 symbol is next to to enter the, the shift with the thing. So you see that the case now is transposed to a vertical order because the actual degrees is row. You see, now it's transposed to a column. So this make it easy to create table which is true. For example, to create a table that convert degrees to radian, enter my table equal to degree post dropping and radian which then MATLAB to get a metric and my table in which column 1 in degrees and column 2 in radians. Okay. So you see here, it is actually from the row, this one. So once you key in this code, it will calculate the radian. So by using this apostrophe symbol, you turn the row into two column, look like a table, but without a caption for each of the column. If you transpose this two-dimensional metric, all the rows become column and all the column become rows. For example, the command my table. So my table was talking result in changing the two column into two rows. So note that my table is not a MATLAB command, but merely a convenient variable name. Okay. So the command is this symbol, the name, my table. So example, scientific data such as data collected from wind tunnels is usually in SI unit. However, much of the manufacturing infrastructure in the United States has been done in English, something called American Engineering or American Standard Unit. They don't need to be fluent in both systems and should be especially careful when sharing data with other engineers. We had the most notorious confusion comes the mass climate orbiter, which was the second flight of the NASA radio system. So the spacecraft burned the peak of Mars in September 1999 because of a table embedded in the cross of the table probably generated that will testing tunnel. Use a pound force when the program expected to in Newton. So in this example, we will use MATLAB to create a conversion of pound force to newtons. The table start at 0 and then go to 100 pound force at 100 pound force interval. The conversion factor is 1.4 to fit. So first thing you need to do is Identify the problem or state the problem. So the problem is to create a table that can convert pound force to Newton. Next is identify the input and output. So for the input is available in the question. The output is what you want to calculate. Develop an example. Since we are creating a table, it makes sense to check a number of different values. Choosing number for which the method is using make the n example is equal to complete. So develop the n example. So to create the table, you need to define the pointers and define the method. Yeah. So the table look like this. So in this case, they use the value, the depth, or is it? Step to transpose the row to look. Test solution next is to test the solution. Exercise 211A. Create the table of conversion configurators. Start the convert 0. So to do the question 2.11A again, you need to use lead space and spaces to create a row of value from 1 0 to 10 given of 1. Then find the unit conversion. Unit conversion for this to feet. Okay. And change the feet. Enter. Uh, so normally the value is the formula. So it is a table you need to transpose. What is this here? What is this? Okay. So number display, although you can enter any number in decimal notation, that isn't always the best way to present a very large or very small numbers. For example, the value that is used frequently accuracy is Avogadro constant. Whose value to force the equal digit is that value. Here are 23. So decimal point. So scientific notation express a value as a number between 1 and 10 multiplied by a power of 10, the exponent. Thus, Avogadro number becomes 6.022 times 10 power of 23. And the diameter of an iron atom, okay. MATLAB value in such information are designed with an E. So that E is referred to exponent power of 10. Between the decimal number and exponent result, we might have 6.00, 6.022 E23. So that is how we write it in MATLAB. So display format, a number of different display formats are available in MATLAB. So changing the display format does not change the accuracy of the result. When element of a metric displayed in MATLAB, integers are always printed with a decimal point. However, values fraction printed in the default format short that show 4 digits after the decimal point like this. A equal to 5 written A equal to 5, but A equal to 5.1, it will return 5.1000. So that is a format short. This is the default format for the MATLAB. So MATLAB allow you to specify other format that show additional digit. For example, to specify that you want value to be displayed in a decimal format with 15 digits after the decimal point, use the command format long like this. So the format long, you write it in the command window. Format long. Notice the word long here turn to purple. So format short also, you see. Then 2 decimal digit, normally we use it to represent currency. So we use format bank. Similar method, just write it in the command window, then press enter. So the bank format display only a real number, so it's not appropriate when complex number need to be represented. So you see the real number is like this value, 51.10. So for imaginary number with I here, so it's written the following bank format 5 A equal to 5.00. So using a format long, the same command return is the how many? Oh, 15 zero. Sorry, 15 decimal point. If you use format long, so you can return the format to 4 decimal digit with the command format short. So to check the result, recall the value of A. So A, okay. Now that you change the format to format short, then the decimal turn to the default, meaning it's 4 decimal a point. So when number become too large or too small for MATLAB to display in the default format, so it will automatically express them in scientific notation with the exponent. So you can force MATLAB to display all number in specific notation with format short e, sit with 4 decimal digit, or format long e with 15 decimal digit. So format short e, format long e. So the e there represent exponent. Another pair of format that are often useful to engineers and scientists is the format short ENG and format long ENG. Similar to scientific notation, but require the power of 10 to be multiple of 3. This correspond to carbon naming convention, for example. So let's see. For format short N ENG and y equals to 1200 to 12,000. So this I'll give value that is with 4 decimal point with exponent 3. So this table show you all the command to display the numeric display from format short to format long G. Out of all the display format given below, which of the following are represented in the individual element of this matrix? Oh, okay. So this is obviously format short to default. This is format bank. This one is format rational. Is format rational. Then the plus is format plus. Okay. Now to script file. So using the command window for calculation is an easy and powerful tool. However, once you close the MATLAB program, all of your calculation are gone, which is true. In the command window, it will just disappear. So for a programmer, they need to save the code. So that code can be saved using a script file. Though the older MATLAB version is called an M file. It's the same thing. This file can be reused anytime you wish to repeat your calculation, meaning it is a safe script. So to open the editing window, select new script from the MATLAB tools tab. So here, script, or just click this one. So this is the script. So once you save it, it will appear in the file space or directory space. Using script allow you to work on a project and to set the list of commands for future use. The command operator in MATLAB is the percentage sign as in this sign. This is a command. So if you use a command, it will turn to green color. So this green color is not part of the code. It's just something that you want to write to as a reminder for you. this code is for which function, something like that. MATLAB will not execute any code on the commented line. So you can also add comment after a command, but on the same line, like this. So a equal to 5 is a command, but after the percentage sign, this is called the comment. So the variable a is defined as 5. So this, after the percentage sign, all of it will turn to green. Yeah, here's an example of MATLAB code that could be entered into a script and used to solve example 2.3. Okay. See, so clear C and C. This is what you write in the script. So just clear and CLC, this one will clear the command window and then clear the workspace. So why you need to clear later on when you run the script, the answer will appear in the command window. So the first two lines is the command. Now it start with the defining the variable. So each of the variable have this a specific command. What does it represent? Then we have another command. Then this CD is equal to equation. So each of the variable here we have identified, or yeah, we have identified, introduce in the previous line is like then another command line to present a different part of the solution. Okay. So once it's ready, you just click run. Yeah. Then it will ask you to save the file first before you can run it. Then save. It will automatically show the result in the command window. Either it's an error or it's okay. Can run to show you. Example. Writing a script to calculate the acceleration of a spacecraft in a lesson of propulsion power kind of spacecraft. Determine based on this equation F equal to ma force. In other words, force is equal to mass times acceleration, and W is the force times distance work. W is work. And since P power per unit time, power becomes force times velocity, because P is equal to W over T, T is time. So F is equal to T over T from the expression W equal to Ft. So this means that the power requirement for the spacecraft depend on its mass, how fast it's going, how quickly it's need to speed up or slow down if no power is applied. The spacecraft just keep traveling in its current velocity. So as long as we don't want to do anything quickly, course correction can be made with very little power. So the power, okay, The two spacecraft that explore the outer solar system is Voyager 1, Voyager 2, uh, which at the moment is is travel outside solar system. Can still continue. Uh, so how much? Okay. So at launch of each of the spacecraft referred to Voyager 1 and Voyager 2, its generator produced about 470 watts of power. Because the plutonium is decaying, the power production has decreased about 335 watts in 1997, 20 years after the launch. This power is used to operate the sign package, but if it were diverted to propulsion, how much acceleration would produce in the spacecraft Voyager 1 is currently traveling at a velocity of 2.5 astronomical unit per year, and Voyager 2 is traveling at 3.15 AU per year. Each spacecraft is weighed around 721.9 kilograms. So state the problem first. So the problem is find the acceleration that is possible with the power output from the spacecraft power generator. The second step is to identify the input and the output. Input we can refer to the equation. The output is the acceleration. That is oh developed developed the hand example. Okay. So for this part, using equation that is derived earlier, P equal to MAV. So we arrange to A equal to, so A referred to the acceleration, so equal to P over mv. So to do this calculation, the unit is important. So 3.5 AU per year, you need to change it to meter per second. So this is the unit conversion, very long. So the velocity for Voyager 1 is 16.65 meter per second. Very, very fast. So A equal to, using the equation, this equation, to be right earlier. So 335, this is the unit conversion divided by m, mass of the spacecraft. multiply with the velocity v, then we get acceleration of 2.7 times 10 to the power of -5 meter per second square. Then let's so once we're done with the hand calculation, then we need to do the MATLAB. We need to transfer the solution to MATLAB. So this is the code. Start with clear CLC. Then the comment, this is example 2.4. This is the question. Find the acceleration for Voyager 1 and 2. Format short G. So this is the uh, uh, variable. Yes, this is the variable. We have mass, power, and velocity. Then the velocity is on this equation, and find the acceleration. So you notice the dot here. You see the dot division, dot multiplication, because it's the velocity is in array. So the velocity for each of the Voyager one is faster, 3.5. AU value, second Voyager 2 is 3.15. So it's in array. That's why you need to use the dot multiplication on the dot uh, division, especially the dot division. Then we test the calculation and then compare with the end example. Section mode. So this is still under script. So section mode, so-called cell mode, is a ability that allow the user to divide the script into sections. So if you didn't divide it, it will run the section, it will run the script as a whole. So from first line till the last line. So if you divide it into a section, it will run section by section. Depend because you can just run it as a whole. Although there's a section, there's a function to do. Then yes, okay. This feature, okay. This feature is useful as you develop the MATLAB program. It's easier to find. We do the debugging to find where is the bug within the line. So we do its section by section. So to divide your M file or script file into section, you create section divider by using the double percentage sign. This see the blue line. It shows that the line 1 and 2 is divided is one section. 3 and so on is another section. Oh, like this. Yeah, it's exercise. So the weight and height of a person are measured in different units in different countries. So create a two-column matrix kilogram pound, where you convert a random set of weight in kilogram to pound. One is in. So to do this, you need the script file or M file. So to to describe the calculation process, you need to do it in a convenient section. So the first section is for the kilogram. Just choose random number to represent the kilogram. Comment just use in space or colon 1 until 10. Create an array. Then create a section. For the next section, you do the, sorry, the unit conversion from kilogram to pound. So there's a command equation that do the conversion. So from there you get this set of value representing that value in kg. But this one for the second section is to convert it to pound. So then create another section to create two columns, meaning to create a table of kg to pound, conversion of kg to pound. So similar method for question B. So this week, shall continue after the break.